Hi, so in this video I want to talk about exponentials and logarithmic functions, which is another class of functions that can expand your differentiating repertoire. Um, it'll let you differentiate more and more classes of functions. So before we begin to talk about logarithmic derivatives, I want to just basically give you the exponential derivatives as a freebie, because it's going to take a while to prove, and I think it's actually better if you just take this for granted, and if you're curious, research more on it on your own time. So the derivative of e to the x is itself, and I think this is really cool because if you make a graph, right? If you make a graph here, and if I draw e to the x, the graph of e to the x, and I'm just going to, looks kind of like that, right? And so this is y equals e to the x, and you have this point here, x equals 2. And if you make the tangent line here to this point at x equals 2, this slope is going to be equal to e squared. And that goes for all x on this graph. So I think that's just really cool. So e to the x is a really special function. And the next freebie I'm going to give you is the derivative of a to the x, which is just any base, not e. That's going to be equal to a to the x times the natural log of a. And I'm not going to really prove that, but that's also nice to know. And the third is going to be kind of random, and you're going to say, why are you telling me this? But we need this, I need you to take this for granted so that we can prove the next logarithmic derivative that we're going to do. And it goes like this. If f and g, and not ang, if f and g are inverses, then g prime of x equals 1 over the derivative of x, 1 over f prime of g of x. And that's, like a weird, relationship, but I need you to take that for granted for now, so that we can prove the derivative of ln of x. So I rewrote this relationship here because we're going to need it for this next bit here. So I want to find the derivative of natural log of x, right? So how do I do that? Well, e to the x and natural log of x are inverse functions. They are inverse functions. You learned that, I don't know, algebra 2 or something. So what we can do is, if we set f of x equal to e to the x, and if we set g of x equal to natural log of x, because they're inverses, we can apply this relationship in blue here. So the derivative of natural log of x is going to be equal to 1 over e prime of f of x. F prime, what am I saying? 1 over f prime of g of x. So it's the derivative of e to the x, but instead of x, we're replacing it by g of x, which is natural log of x. So what's the derivative of e to the x? That's e to the x. It's just itself. Now, so f prime of g of x is going to be e to the ln of x. So it's e to the ln of x. And that's a bit of that chain rule. It brings a bit of those chain rule skills into play here when you're talking about f prime of g of x. And what is this? We also maybe learned in algebra 2 or pre-calc that if you have e to the ln of anything, it just simplifies to that anything. So this just becomes 1 over x. And since we can't simplify that further, that becomes our derivative. The derivative of ln of x is 1 over x. So that's our first discovery in this video. And we're going to make one more discovery, and that's going to be, what is the derivative of any logarithm? Log base a of x. Well, in pre-calc maybe, or maybe you don't know, and this is your first time learning about this, there's a change of base formula, which states that log base a of x is equivalent to saying ln of x over ln of a. You can change the base from log base a to ln of x over ln of a. And this could be log base 2 of x over log base 2 of a, but we're choosing ln because it's going to come in pretty handy. So if this is an equivalent, it's an identity, is basically what it's saying. They're equivalent. So this derivative becomes ln of x over ln of a. And we can take out a 1 over ln of a, because it's a constant, because a is a constant, times ln of x. So we can bring that out of the derivative, because it's just a scalar, it doesn't matter, dx of ln of x. So we forget about the 1 over ln of a for now. And what is the derivative of ln of x? Well, we just figured it out. It's 1 over x. So this is going to be equal to 1 over ln of a times 1 over x, which is equal to 1 over x times ln of a. So those are the two main things that we figured out this video. And don't forget that the derivative of e to the x is e to the x, and the derivative of a to the x is a to the x times ln of a. And that's basically it.